Okay, number one on the test 10 study guide, the ratio of good guys to malefactors was 4 to 6. They gave us categories of good guys, malefactors, which is bad guys. I'm going to say G for good guys, N for malefactors. I put a ratio column. The good guys 4 to malefactors 6, so 4 to 6. And then it goes on to say if there were 36 good guys, so we're looking at the actual number of things here, exactly 36 good guys, how many malefactors were there? That's what we're looking for. So we create this nice organized chart. It creates a proportion, 4 over 6 equals 36 over x. We cross multiply this product for x is equal to this product. 6 times 36 is 216. Then we simply divide both sides by 4 to get rid of that number in front of x. And 216 divided by 4 is 54. You should expect on the test to have malefactors and good guys in some ratio. I'll tell you the number of good guys, ask you for the number of malefactors. So it should set up similarly. Ratio of gaudy scarves to tawdry scarves was 3 to 7. There were 120 scarves in the pile. So the difference between this one and the last one, other than the fact we're talking about scarves instead of good guys and bad guys. And so they give us that initial ratio. So we have gaudy scarves and tawdry scarves. And if we set up this ratio and actual thing, gaudy 3 to tawdry 7. Okay? The difference here is this says there were 120 scarves in the pile. It doesn't say 120 gaudy scarves, it doesn't say 120 tawdry scarves, it says 120 scarves with no inscription. So that means we have to get a third row going on here that says total. And if we add the ratio numbers up, 3 and 7 make 10, that gets me the total ratio number. So when it says there's 120 scarves, the total number of scarves is 120. How many were merely gaudy? So we're looking for gaudy scarves. This tawdry no longer is necessary to look at. So again, that 7 was needed to get this 10, but we know gaudy ratio 3, total ratio 10. Actual number of gaudy is what we're looking for. Actual total number is what we're given, so we're able to do that. So 3 over 10 equals x over 120. We cross multiply that product 10x equals that product 360. And if 10x equals 360, we divide both sides by 10. That leaves me with x equals 36, and we found gaudy scarves. So 2 ratio problems. One doesn't contain total, the other one does. So be careful that you make note of that when you're doing the test. Number 3, write an inequality describes this graph. Writing inequality requires you to pick a letter. Write the number where the dot's happening. Okay, leave some space. Always put the letter on the left, dot on the right, or whatever the dot number is on the right. And then the inequality is pointing this direction. So whatever that's pointing, make sure this points the same way. And then this has a solid circle. That gets me an equals to. That's all it is to write an inequality. It's only asking for the inequality, so just give me that for that answer. Number 4, simplify. Now, a few of us had trouble with this in the last test. Anytime you deal with a power, you need to see what the power is affecting. When parentheses are involved, it's affecting this entire thing. So this thing is being raised to negative third power. The 1 and the minus sign aren't. So the 1's going to stay right where it's at. The minus sign is going to stay right where it's at. This guy here, negative power belongs on top. So the negative 2 stays encased in parentheses, being raised to the positive third power. Once we move it up to the top. And I can't have over negative, so I'm going to put a 1 down there just to have something down there. Then I'm going to evaluate, and again, what's being raised to the power is negative 2. That means negative 2, negative 2, negative 2. 2 times 2 times 2 is 8, and 3 negatives making a negative 8. It's being multiplied by the 1, so negative 8, which is what this whole thing is, times 1, still over the negative 1 down here. 1 times negative 8 makes negative 8, and negative 8 over negative 1, 2 negatives make a positive. So positive 8 would be the best result for that one. I would accept 8 over 1 also. I would rather not have 2 negatives in the final answer. So make sure you get it down to either positive 8 or 8 over 1. Number 5. 5.05, a decimal number of 0.02, a number is equals what number? So 5.05 of something means to multiply. So when you see decimal of, it means decimal times the next thing. Is means equals, and what number is x? So all we have to do to get the answer is multiply 5.05 times 0.02. I'm fine using a calculator for that. So 5.05 times 0.02. Make sure we typed it in correctly. It equals 0.101 is the answer. Feel free to use algebra to translate words into an equation, but then use a calculator to calculate some stuff that you should have mastered back in 5th, 6th, 7th grade. So my goal in algebra is not to teach you how to multiply decimals. My goal is that you know how to multiply decimals. Feel free to use a calculator to calculate to save time. Number 6, f of x equals. Anytime you're given a function, which is what this is, f of x, f names the function, x is the variable. You can see here is negative x squared plus 5. And again, I see a power happening here. What's being raised to the power is x, not the minus sign. It's x to the second power. The minus sign is not being raised to the power. They want me to do f of 4. So they're changing x to 4. So to work this out, I'm going to change x to 4. So what happens here, the minus sign, I'll keep everything that's supposed to stay the same in black. So the minus sign stays minus. I'm changing x squared into 4 squared. X became 4. X is being squared, so 4 is being squared. The minus sign still is not being squared. And then we got plus 5, which is just hanging out. So that's all we're doing. F of 4 means to come over here, change x to 4. And then work it out. 4 squared is 16. The minus sign is not being squared. And once we've evaluated 4 squared down to 16, so now we have negative 16 plus 5. Now we have to add or subtract based on signs. The signs are opposite, so I subtract. 16 is bigger, so it's negative. Number 7, solve. Okay, anytime we're trying to solve, our first priority is going to be to get all the letters to one side, all the numbers to the other, if there's no parentheses, which there aren't. So I would probably start by moving this 4 over here. If you move a 4 across, it's negative 4, it becomes positive 4. So if I add like terms, 1.4 plus 0.2 is 1.6p. And 5.6 plus 4 is 9.6. Okay, this is 4.0 if you want to get really technical. 6 and 0 make 6, 5 and 4 make 9. The decimal point remains between. 1.6p is equal to 9.6. We divide by 1.6. Again, you're supposed to master division of multiplication of decimals in 5th, 6th, 7th grade. Again, if you're not comfortable with that, 9.6 divided by 1.6 equals. Okay, I don't want you to do algebra right and get an answer wrong because you calculated on your paper instead of a calculator on your test. So if you know how to do algebra, that's great. That's what this class is called. One other thing we could have done on the same problem that you may prefer to do, and it's up to you if you want to decide to do this or not. If I have decimals, if I get everything down to the same number of decimal places, one decimal place, this doesn't have any to begin with, so 0.0 has 1, 5.6 has 1. Then you drop all the decimals off, 14p plus 2p minus 40 is equal to 56. Get it as a non-decimal problem. That gets me 16p is equal to 96. You get the same answer, 96 over 16 still is equal to 6. Verify that. 96 divided by 16 equals 6. So take your pick. If you don't like decimals, you can get rid of them. That seems simple enough to me that I didn't even worry about it. Number 8. We're supposed to solve p minus 5 parentheses p minus 3 plus equals 6 plus parentheses 5 minus 3p. So first thing I notice is we have distributive property going on here, so I'm going to multiply through that parentheses. This is plus 1 officially being multiplied by the parentheses also. So if I do that, this p is not being affected. It is 1p. You might want to put a 1 there just to remind yourself there is 1. Negative 5 times p is negative 5p. Negative 5 and negative 3 is plus 15. Be careful when you distribute the sign is being multiplied along with the number going through there. Then I got a 6, and this time I have a positive 1 being multiplied through, so positive 1 times 5 is going to be plus 5. Positive 1 times negative 3p is minus 3p. Notice in both cases I have p minus 6 plus. The p and the 6 aren't affected by this distributive property. All affected after the minus sign, The minus 5 is being multiplied, the positive 1 is being multiplied. Be careful with the distributive property. That number being multiplied by parentheses is what's being multiplied through. Next thing I would probably do is combine like terms. So over here we have like terms there, over here we have like terms there. So 1p minus 5p is negative 4p. Subtraction because the signs are different, negative because 5 is bigger. 15 just comes along for the ride. Over here 6 and 5 is 11. Addition because the signs are the same, positive because 6 is bigger. And now I'm at a point where I've got letters on both sides, numbers on both sides. I would probably move the 4p over here. Minus 4p becomes plus 4p when you move it across. Move the 11 to the other side. Plus 11 becomes minus 11. 15 minus 11 is 4. Negative 3p plus 4p is going to be equal to positive 1p. Subtraction because the signs are different. Positive because 4 is bigger. 1p is the same as p. So p equals 4. If this said like 5p equals, then I have to divide by 5. So that's the extra step that might happen. But that's what you want to do. So distributive properties, simplify, combine like terms to finish simplifying. Isolate p, isolate number, and then again divide if necessary, which it wasn't in this case. Number 9, same basic difficulty problem. We got distributive property going on here, distributive property going on here, and just some stuff going on over there that's going to just come along as we do the distributive property. So 4 is being multiplied by 3 minus x. 4 times 3 is positive 12. 4 times minus x is minus 4x. Positive 2 is being multiplied by x minus 5. Positive 2 times x is positive 2x. Positive 2 times negative 5 is negative 10. Again, nothing happens to negative x plus 5 but bring it down. Second thing, combine like terms. Over here, negative 4x and 2x are like terms. That makes negative 2x. I subtract because the signs are different, and it's negative because 4 is bigger. 12 minus 10 are like terms. It doesn't matter, they're separated by a bunch. There's the equal sign. They're on this side together. They're like terms. 12 and negative 10 subtract because the signs are different. 12 is bigger, so it's positive. Still equals negative x plus 5. That right-hand side just keeps coming down. I'm not doing anything to it. What's left now, I've got letters on both sides, numbers on both sides. Again, make a decision. We're going to move 2x over to the right-hand side. Move 5 over to the left-hand side. Negative 2x became positive. Positive 5 became negative. This is negative 1x that's over here. I might have done that initially just to make sure there's a number there. And then it's just a matter of adding or subtracting based on signs. These signs are different, so I subtract. 5 is bigger, so it's negative. These signs are different, so I subtract. I get 1x, it's positive because 2x is bigger. Once again, x equals negative 3, it's already solved. I don't have to divide by anything because there's no number in front of x. Again, if it said something times x, divide by that something in this step. Number 10, simplify 4xy plus 16xy squared over 4xy. I don't know how to explain this any better than I have, but I'm going to try. 4xy, 16xy squared, 4xy. There's 3 separate terms there. Each one of those terms has to divide by the same thing to reduce. Okay, so the answer I'm going to try and create here is going to have the same structure. Something plus something over something. I need to divide by the biggest thing possible I can divide by in each case in order to make this the best answer possible. So I can see very clearly that the number 4 goes into all 3 numbers, 4, 16, and 4. X to the first, x to the first, x to the first. Y to the first, y to the first, y to the first. So this says y squared, but this has a y to the first instead of these. These don't have y squareds in it, so y is what I can take out. So you can take out the highest power of any letter that's shared, or sorry, the lowest power of any letter that's shared, and you can take out the biggest number that can be taken out. So if I take each of these divided by 4xy, 4 divided by 4 is 1. Always write down the ones. X divided by x cancels, y divided by y cancels. 16 divided by 4 is 4. X divided by x cancels, y squared divided by y is y. 4 divided by 4 is 1. X cancels, y cancels. So 1 plus 4y over 1, or just 1 plus 4y, since over 1 doesn't have to be written. I'd take either answer. I'd probably go down to there myself, though. It's going to be just like that on the test, number 10. There's going to be a common factor. You should be able to find out what the common factor is, and then just divide each object by that common factor. Number 11, simplify. What we're looking at is we have too many x's, and we have too many y's. So we have to make a decision where x and y both belong. X belongs on top because 5 is bigger than 3. We subtract, we get 2. Y is bigger on bottom, so Y belongs on the bottom. 5 minus 3 is 2. The end. Where does it belong? What is the power? Where it belongs is the higher power's location. The power should be the subtraction of powers big minus small. If it goes on top, top minus bottom, bottom minus top. Always do big minus small, it makes life easier. So, x squared over y squared. I do not want negative powers in the final answer on these problems. Number 12, same basic idea. The only problem is we have a negative power in this one, so I'm going to move this down where it belongs. I'm also going to put first powers where they belong. So initially, before I start worrying about where things belong and that kind of stuff, I would make that happen. So I would rewrite the problem into a better form. So negative powers disappear, they become positive powers, and first powers get written on there. Then looking at each individual piece, x, y, and z individually, x is being divided by x, so I have to make that decision. Where does x belong? Top, power, 4 minus 2 is 2. I look at y, y is only on the bottom, it's being multiplied, so y belongs on the bottom. Multiplying letters, we add powers. 1 plus 5 is 6. But again, I'm adding powers on the bottom because that's where y is located. And then if I look at z, I've got z on top, z on bottom, they're being divided. So again, that's a decision, where does it belong? Bottom, because 4 is bigger. What's the power? 4 minus 1 is 3. 1x, 1y, 1z, all powers positive. That's what we're looking to do every time on these problems. Again, if they end up on opposite sides of the fraction, we put the answer where the bigger power is, subtract. If they end up on the same part of the fraction, we're going to add the powers together and leave the answer wherever they're at. Number 13, expand using the distributive property. I would begin by fixing each object. So this has a negative power. There's absolutely nothing wrong with this, but I'm fixing something, so I'm going to move it down. And this has negative power. So I need to fix the red and the blue, and the green just going to come along for the ride. So, parentheses still here. Fixing the red, x cubed belongs on top, a to the 5th is right where it belongs because it's positive power. Since everything's on top, I'll put it over 1. There's fractions in the problem, it's good that everything looks like a fraction. Minus, again, the green term is behaving itself. X cubed is positive, a to the 5th is positive. It doesn't matter about the minus sign, it just creates a negative answer. And then this other one, x cubed belongs on top, a to the 5th belongs on the bottom. So that's job one. Get the problem written as simply as possible. Then we distribute. When we distribute, we go from the outside piece to the leftmost piece of the parentheses. I see a lot of you going here first, then there. Always go all the way to the left of the parentheses. The first term in the parentheses is what gets multiplied first. We do top times top, bottom times bottom, and then don't even worry about things canceling here. Just get what you get. So for top times top, I'm multiplying x's and a's. All right? There's only one a, so nothing happens to it. There's two x's. We add 3 and 3 to get 6. On the bottom, 1 times a to the 5th is a to the 5th. Move on to the next one, this multiplication, minus. Okay, I've got x times x on top, I add the powers. I've got a times a on the bottom, I add the powers. Okay. Once you've multiplied, now worry about reducing if possible. And you can see here that this term has too many a's on it, specifically a to the 5th are on the same part of the, on different parts of the fraction. They cancel. So x to the 6th is all that's left over from the first term. The second term is perfectly fine. There's one x, there's one a, and this should be a 6 instead of a 3. I don't know how that 3 showed up there. Going back real quick, x cubed times x cubed, 3 plus 3 is 6 here. All right? So x to the 6th, a to the 10th, there's just one of each letter, so minus x to the 6th over a to the 10th. This is separate from that. This fraction ends right here. I see people still going all the way across that fraction bar, minus this fraction. That's not a fraction, this is a fraction. That's our final answer. Number 14. If anybody watches this video and doesn't do what I'm about to do, I can't help you anymore. I'm just at a point where I'm getting frustrated with people not listening to anything. So here's an expression. That's the exact same expression that'll be on anybody's test. So when you get your test, whatever day it is, when you get it, it's going to be that exact same expression. The only thing I change on these problems is these. And this will still be positive, it'll still be negative. I don't even go so far as to change signs of things. But A is going to be a different number, B is going to be a different number. A will be positive, B will be negative. Here's what I'm going to tell you right now that some of you aren't doing, and if you do this, you'll get the right answer more often than not. A parentheses 1 minus AB. Because I'm going to say these words for about the 25th time this year. It doesn't matter what B equals if B is to the 0 power it equals 1. And if you just go ahead and make it 1 immediately, before you stick a number in there, then you don't have to worry about a minus sign being there. Well, it should be -1 now, or it should be +1. It's 1. This equals 1 100% of the time, every single time, as long as b doesn't equal 0, which it won't in these problems. So, for the sake of these specific problems here, it will always, 100% of the time, equal 1. It will never equal anything but 1. That's what b to the 0 power equals, always. So if you go ahead and write it down, then you don't have to worry about that anymore. The only thing I have to worry about, really, is this a times b. If I look at a times b, a is 4, times b is -2. That makes -8. Okay, that's what AB is equal to. So if I come over here and then I'm going to try and evaluate this thing, a, which is 4, is being multiplied by 1 minus AB, which makes 4 times 1 plus 8, which makes 4 times 9, which is 36. Some of you still want to do distributive property. 4 times 1 is 4, 4 times 8 is 32, then add it together. Go ahead if you want to. I never found it easier than just, if you can add stuff, go ahead and add them. Alright? Minus minus makes a plus, they're the same sign, so I added. 9 times 4 is 36, I'm done with the problem. This will be b to the 0 on the test, this will equal 1. I can't help you if you don't want to do that. So that's where I would start off on this problem. And again, if you just figure out what AB is, stick it there, stick A there, 2 negatives make a positive. If AB happened to be positive, it would be minus a positive number there, so 1 minus a number. But that shouldn't even happen because it's going to be a positive number or a negative number on the test. So that's what it's going to look like. Number 15, find the area of the shaded portion of this figure. Dimensions are in centimeters. I can say I have a trapezoid with a circle being cut out of it. To do shaded portion, we have to find the area of the trapezoid minus the area of the circle. Okay, so if we look at the trapezoid, the area formula for a trapezoid is 1/2 times the sum of the bases. Okay, the bases are the 2 parallel sides. If I add those 2 things up, I get 95. Times the height. The height is how far apart the bases are separated. Base 1, base 2 separated by a height of 20. That's how you find area of a trapezoid. It works every time. It's basically like an area formula for a triangle. 1/2 times base times height. Only this is bases because there's 2 of them. So the 2 parallel sides of the bases, add them up, get the area of a trapezoid. The area of a circle is pi r squared. Okay, the radius is 10. 10 squared is 100, so that's r squared. All right, so a trapezoid formula, circle formula, then we multiply it all out. 1/2 of 20 is 10 times 95 is 950. 100 times 3.14 is 314. 636 centimeters squared is what I get. And again, if you're unsure of something or if you want to be sure of your calculations, once you get this figured out here, you just type in 1/2 times 95 times 20 minus 3.14 times 100. Type in exactly what you see there, it equals. It'll spit out the right answer for you. Again, I don't want you missing stuff because of calculation errors. Feel free to use a calculator to verify your solutions, or even if you want to do it in the first place that way, that's fine. Just be careful you type it incorrect.